Up to this point, I have discussed coordinate system, distance formula and section formula. In this video, we will look into different points of triangle, special points, and the prerequisite for this lesson will be distance formula and section formula. So let's begin. What are the points that we will be discussing? Centroid, circumcentre, orthocentre, incentre and excentre. There will be total 13 questions and I'll be discussing concepts as we move along the questions. Alright, so let's start with the centroid. Centroid, and I assume you know the concept of median. Let's draw any arbitrary triangle. 3 vertices A, B, C. Median is line segment which connects the midpoint of opposite side. So this is median. This is another median. All 3 median intersect at a point which is called centroid. Alright, and this is usually denoted by G. These are what? Medians. Also, one important property that you may be aware, that this centroid divides all the medians in 2:1 ratio. Let's say these points are x1 y1, x2 y2, x3 y3. To find the coordinate of centroid, what we can do, we can use section formula on any of the median. Let's pick this one, name it D. So D is the midpoint of BC. So the coordinate of D will be x2 plus x3 over 2, y2 plus y3 over 2. By using section formula, you can figure out the coordinate of centroid, right? This is the formula that I have already discussed in the last video. So let's do that. 2 times this one, x2 plus x3 over 2, plus 1 time x1 over 2 plus 1, 3, right? And similarly for y coordinate also, plus 1 time y1 over 3. And if you simplify this, the coordinate of centroid becomes x1 plus x2 plus x3 over 3, y1 plus y2 plus y3 over 3. Let's try to solve few questions. At least I think first and second we can do using this simple basic concept. So the first question is, if vertex A of triangle is 3, 5 and centroid is negative 1, 2, find the midpoint of BC. A is given 3, 5. B we don't know. Let's name it x2 y2, x3 y3. This point is given negative 1 and 2. We have to find midpoint of BC. This point, right? What is the midpoint? x2 plus x3 over 2 and y2 plus y3 over 2. The centroid is already given. We have to just apply the formula. x1 plus x2 plus x3 over 3, y1 plus y2 plus y3 over 3. x1 y1 is given, so that is 3 plus x2 plus x3 over 3 is what? X coordinate of centroid, that is negative 1. So x2 plus x3 is what? Negative 3 and negative 3, negative 6. Similarly for y coordinate, y1 is 5, y2 and y3 we don't know. Y coordinate of centroid is 2, so y2 plus y3 is 6 minus 5, 1. So the midpoint of BC will be, or the point D will be, x1 plus x3 over 2, that is negative 3, and y2 plus y3 over 2, that's 1 over 2. This is the answer. Let's try second question. A triangle has a vertex at 1, 2 and the midpoint of the two sides through it are -1, 1 and 2, 3. Find the centroid of this triangle. Question 2, and we don't need any additional concept. The formula of centroid is good enough. So one point is given, that is 1, 2. B and C we don't know, so let's write that x2, y2, x3, y3, and centroid is given. Oh, centroid is not given. We have to find the centroid. The midpoint of two lines are given. Those are -1, 1 and 2, 3. All right. We have to find this point. How to do that? This is what? This is midpoint, right? This is midpoint of AB. This is midpoint of AC. If the midpoint is given and one coordinate is also given, we can easily figure out the other coordinate. Right? Midpoint is nothing but average of two values. Like here, 1 plus x2 over 2 is what? -1. Right? So x2 is -2, -1 is -3. All right. And for y2, 2 plus y2 over 2 is 1. So y2 is 2 minus 2, 0. Similarly for this segment, 1 plus x3 over 2 is what? 2. So x3 is 4 minus 1, 3. For y coordinate, 2 plus y3 over 2 is what? This 3. So y3 is 6 minus 2, 4. So what are the coordinates? x2, y2 is -3, 0. x3, y3 is 3 and 4. And once we know the coordinates of all 3 points, it's very easy to calculate the centroid. We need to just add, right? 1, -3 plus 3 over 3 and 2, this is 0, and 4 over 3. This will be 1 over 3 and 6 by 3 is 2. This is the answer. Before moving to next question, let's understand one more concept that is also related to centroid. And probably you might know this when you studied basic geometry. Centroid divides complete triangle into 6 equal areas. So this area, this area, this area, this area, this area, all are same. Okay, so let me write it. The 3 medians, you can note down, of a triangle divide the triangle into 6 equal area. Also, if we just see this, this area will be same as this one, right? If everything is same, you're just adding 2 areas. That will be your third one. So these are all same areas. Here 3 areas are same, here 6 areas are same. And based on this question, we can attempt third one. Let O, P, Q, 3 points are given. Let's draw. 3 points are given, O, P and Q. Okay, O is 0, 0, P is 3, 4, Q is 6, 0, these 3 points. And it says these are the vertices of triangle OPQ. Find the point R inside the triangle OPQ such that the triangle OPR, any point R, we don't know, right? What is this point R? It says area of OPR, this one, PQR, and the other ORQ or OQR are having equal area. So this point must be centroid, right? And once the points are given, you can easily figure out centroid. Just add all together this 0 plus 4 plus 0 over 3. So the answer is 3 and 4 over 3. And we are done. Question number 4 introduces another important point, that is Incentre. So let's understand what is Incentre and Excentre. Derive the formula for both and then we can look into further questions. I think 4, 5, 6, 7 also we can do after understanding that. Probably 8 also. Okay, let's do that. Incentre or this one. Let's draw any arbitrary triangle. Incentre is nothing but the center of circle that touches all the sides. Hopefully this will not be perfect circle, but okay, the circle which touches all the sides, the center of the circle is Incentre. And how to get that point? You can draw angular bisector of each angle. Oops. This also. Alright, so here the angles are equal. This angle is, these are same. Okay, and this point is this one is called, this is in circle, and the radius of this circle is in radius. All right. If we draw perpendicular, this radius is called, generally this is denoted by small r, that is in radius. When you study circumcentre, their circumradius is denoted by capital R. And you know, by convention we write this as ABC. If you're not interested in the derivation of this one, you can directly remember this. This is generally denoted by I. So this will be AX1 plus BX2 plus CX3 over A plus B plus C. These are side length. AY1 plus BY2 plus CY3. A plus B plus C. That's the formula of Incentre. But let's do the derivation because this is very easy, and during derivation you will know few more concepts that can be useful for problem solving. For example, in what ratio this Incentre divide this line? When the lengths are given, we can easily figure out. The answer will be B plus C over A. This will divide in A plus C over B, like that. Let's do that quickly. If you're not interested, you can skip it. Also, angle bisector theorem will be used in this. A, B, C. Let me do it fast. These are same angle. Define one point D. And by angle bisector theorem, you know the ratio of this one BD and DC will be same as AB and AC. This is C, this is B, and the bottom one is A, right? So why we are always talking about ratios? Because we know the section formula, and once we know the ratio, we can easily figure out coordinates. BD over DC is C over B. If this is C and B, and this is X2, Y2, X3, Y3, X1, Y1, you can easily figure out the coordinate. D will be what? If this is C over B, these are not exact length, these are just ratio. So this will be B, Bx2 plus Cx3, B plus C, and again By2 plus Cy3 over B plus C. So far good, we know the coordinate of this. How to figure out the coordinate of this one? Again we will repeat the same exercise in this triangle. Why in this triangle? Because again we have to find the ratio, right? We will figure out the ratio and then find the coordinate. Same logic. This is also angle bisector. So this ratio will be related to the side length of AB and BD, right? In this triangle, AB we already know, BD we don't know, but BD we can easily figure out. How to figure out? Let's do that quickly. Using this itself, if we add both sides 1, why we are adding? Because by this way you will get A, right, in this equation, BD plus DC. So BD plus DC is what? A, right? A over DC is B plus C over B, and DC is what? DC will be something, but we are interested in BD, right? So let's reverse that. DC over BD is B over C. Just add both sides. BD plus DC is what? A, right? A over BD is B plus C by C. BD is AC over B plus C, and the ratio in which this will divide, here we have C, and this is what? AC over B plus C. So the ratio will be, so this ratio will be what? AI over ID will be what? This over this, right? C over AC, and then B plus C. So this will become B plus C over A. This is very important result, right? Let me simplify it. A, B, C. If this is Incentre, the ratio of AI over, let's say this point is D, the ratio of AI and ID will be, B plus C over A. And once you know the ratio here, this point we have, right? Bx2 plus Cx3 over B plus C, and again we know the ratio, the division of this AI and ID, so you can easily figure out this one, and this point will be Ax1 plus Bx2 plus Cx3 over A plus B plus C, and similarly for y coordinate also. Let's understand the concept of Excentre. Excentre is very similar as Incentre. X means outright, in means inside. So this is Incentre, you know, the angle bisector of 3 angles. If you extend this further and take angle bisector of these 2 angles exterior, you will get one point which is Excentre. This is I. Generally we write it as I1, and you can do it with this side also. You will get another point I2. This is I3. These angles are same, and this is also bisector. And these points I and I1 are harmonic conjugate of each other. Conjugate. The meaning of harmonic conjugate is if this one divides internally into some ratio, this one will divide exactly in the same ratio but externally. While deriving the formula, we know this divides internally in B plus C over A, right? Internally, so this will divide in B plus C over A externally. Again we are seeing the fraction, right? And using section formula you can easily figure out the coordinate of this point. One more important point, this Excentre will be the center of circle which touches all 3 sides. I am directly writing the results. I1 will be, the formula is very similar as Incentre. This is formula of Incentre, right? A plus B plus C, and AY1 plus BY2 plus CY3 over A plus B plus C. You have to just put negative sign on A here. Alright, so this becomes Excentre coordinate opposite to vertex A. Similarly for I2, this will be A minus B plus C. Oops, I think I did one mistake here. This will also be negative. How to get this? Simply this dividing externally in this ratio, so you can figure out. And AY1 minus BY2 plus CY3, A minus B plus C. I3 will be negative sign on C. a plus b minus c and by2 minus cy3 over a plus b minus c. Now we know centroid, Incentre and Excentre. Let's attempt few questions. Question number 4 is very straightforward, just the application of this formula so that you know how to calculate. Find the centroid and incentre of the triangle whose vertices are 2, 4, 6, 4 and 2, 0. Let's do that. Is what? 2, 4, B is 6, 4, C is 2, 0. This is basically x1, y1. This is x2, y2. This is x3, y3. To calculate the centroid, you don't need to calculate the length of each side. Centroid will be just 2 plus 6 plus 2 over 3 and 4 plus 4 plus 0 over 3. That is 10 over 3 and 8 over 3. Let me erase this. To get the coordinate of Incentre, we need to find the length of each side. And a y1 plus b y2 plus c y3 over a plus b plus c. What is a? This one is a, this is b, this is c. If you apply distance formula, this will be 4. This will be 6 minus 4 plus 4, 16, 16, 4 root 2. And b will be again 4. So now you know a, b, c, x1, y1, x2, y2, x3, y3, and if you put all together you will get the answer. I'm just writing the answer. You can try calculating this. 6 minus 2 root 2 and 2 root 2. Let's move to next question. Question number 5 is find the incentre of triangle with vertices 1 root 3 0 0 2 0. Okay, actually we don't need to apply this formula, Incentre formula, in this question. We can directly use centroid, and the reason of that is the triangle that will be formed by the vertices, those are given, that forms one equilateral triangle. If the triangle is equilateral, A, B, C will be same, right? The length of sides are same in equilateral triangle ABC. So this will become this. So always remember centroid and incentre are same in equilateral triangle. Okay. And since the coordinates are very simple, you can easily figure out. One point is 0 0, other is 2 0. Next is what? 1 root 3, 1 root 3. What is the distance of each side? This is 1 and 3, so 2, 2 and 2. And since this is equilateral triangle, you can just add the coordinates and divide by 3. 1 plus 0 plus 2 over 3 and root 3 plus 0 plus 0, is it? Okay, so this becomes 1 and root 3 over 3. You can simplify this also. 1 and 1 over root 3. Although you can use this formula also, you will get the same result. Now moving to next question. Find the incentre of the triangle formed by lines y equals mod of x and y equals 1. Let's do this. Question 6. Although we have not started a straight line formally, but y equals x is straight line. It's very simple, right? X and y, when y and x are same, this will always be straight line like this. And when y is mod of x in this negative, this will become this one. Alright, so let's plot that. This is what? Y equals mod of x, right? Just mirror of this side because absolute value of x we are taking, right? Other line is y equals 1, and this one was this point is obviously 0 0. This point is what? If y is 1, obviously x will be 1 1 1. Just mirror of that, so x will be -1 and y is obviously 1. And when 3 points are given, you can easily figure out using formula a plus b plus c, right? Distance formula. Find the distance of all these three. Coordinates are already given. I will be giving the answer 0 2 minus root 2. Moving to next question. Question 7. Question 7 is, if the sides of triangle ABC are given ABC, find the ratio in which Incentre divide the angle bisector of B. This we already saw here, right? If you go back in this video, you will see the ratio we already saw. So the triangle is this one, A, B, C, and it is saying bisector of B. Alright, so this is A, this is B and C. So the Incentre will divide in the ratio of sum of these two divided by this one. So C plus A by B. Just put those numbers. 6 plus 4 over B is 5. That is 2:1. Very simple question. Next one is also similar. If the side of triangle ABC are such that A is 4, B is 5, C is 6, find the ratio in which the Excentre corresponding to angle A divide the angle bisector of A. Okay. So here I think triangle is same only ABC. So what we can do here, this one Excentre here, this point, this will divide in what ratio? B plus C over A, right? And this is harmonic conjugate, so this will be externally. What are the values? C is 6, this is 5, A is 4, so B plus C is 6 plus 5 over A is 4, that is 11 over 4 externally. And we are done. Next two questions, number 9 and 10, are related to orthocentre. So let's understand what is orthocentre. Orthocentre is nothing but the point where all the altitude meets. Altitude means draw perpendicular from vertex, this one, and also this one. Okay, these are what? Altitudes. Altitude. This is orthocentre, and this point is usually denoted by H. Alright, there is one formula also, but that is not very useful. You can make a note. When the angles are given A, B, C, you can find out the coordinate of orthocentre using this formula. x1 tan of this angle, x2 tan of B, x3 tan of C over tan A plus tan B plus tan C, and also same way for y also. Just replace x with y1, y2, y3, that will be y coordinate. But this is rarely used formula. Also important point of orthocentre, centroid and incentre always lies within the triangle. Any point, this could be any point. Orthocentre may or may not lie within the triangle. For example, in this case orthocentre was within the triangle, right? This is within the triangle. But let's say you are dealing with obtuse angle triangle. Obtuse angle triangle is what? Where one angle is more than 90 degree, right? So altitude is what? Altitude is altitude from this to this will be this A, B, C. From A, from B it will go somewhere this. C to this we need to extend this, right? Assuming this is 90 degrees, so it will somewhere down the line it will come here. This is another altitude, so it may go outside. Now take special case of right angle triangle. In right angle triangle, orthocenter is this point where right angle is formed. Why? Because this itself is altitude, right? This one. So this is important result. In right angle triangle, this point is orthocenter where 90 degrees formed. Let's solve question number 9. Find the orthocenter of the triangle whose vertices are 0, 0, 3, 0 and 0, 4. By looking into the number itself, it is clear that this is right angle triangle, right? X, Y. So 0, 0, 3, 0 and 0, 4. We need to find out the orthocenter of this triangle. Obviously this is 90 degrees, so orthocenter is nothing but 0, 0. This is the answer. Another important result of orthocenter is, if you know trigonometry you can easily derive it, but I'm just writing the end result. This is altitude. Also this is related to question number 10. In the triangle ABC, the angles are given. Find the ratio in which orthocenter divide the altitude AD. When angles are given, the ratio in center we know, right? What is in center? It divides in, if this was in center, right? Angle bisector, this will be B plus C over A. Similar pattern here also we have. AH over HD is tan of B plus tan of C over tan of A. Just put the value. A is 45, B is what, 60 and 75. So tan 60 plus tan 75 over tan of 45. If you put the values, you will get the answer 2 plus 2 root 3. Alright, so ratio is very important. In medians, you know what is that? 2:1. In center, that is sum of two sides by another side. So this will vary depending on which median you are taking. Similarly for orthocenter, this is another, just put tan here, right? Tan of B plus tan of C over tan of A. Now question number 11, 12 and 13 we are introducing circumcenter. Alright, although orthocentre and maybe centroid is there, but we need to understand what is circumcenter before attempting any of these questions. Circumcenter. Circumcenter is basically the point where perpendicular bisector meets, like this one and this one. These are perpendicular bisector. This point is called C, that is circumcenter. Also, one important concept of circumcenter is that a circle will circumscribe this triangle, and this radius is called, by convention, this is capital R. So this is circle, this is circumradius. The way we learn in radius, here it is circumradius. Another concept, as we know, centroid and incentre will always within the circle. Orthocentre may or may not lie within the triangle. If the triangle is obtuse, it will be outside. Similarly for circumcenter, triangle is obtuse, this may lie somewhere else. This is circumscribing, right? But the circumcenter is outside this triangle. You can have so many triangles where Circumcenter is same for all this triangle. Like you can draw one more, maybe this one here. You got the point, right? Here it is obtuse, more than 90 degrees, so this is outside the triangle. Here this was inside the triangle, right? Within the triangle. The special case of this one will be right angle triangle, right? So right angle triangle, you know this point is what? This point is orthocenter. These are important results that can help you in solving the question fast. Circumcenter in this triangle is midpoint of this hypotenuse, right? If this is perpendicular bisector and let's say this is also meeting somewhere here, this one. If you look into two triangle, this triangle and the bigger triangle, right? This is perpendicular bisector, we know. If you look into this triangle and the bigger triangle, it is very obvious that these are similar triangles. So if the ratio is 1, right, 1:1, this is bisector. So obviously the ratio here will also be 1:1. So this will be midpoint. So the midpoint of this one will be what? Circumcenter. Also there is one formula for circumcenter, but that is also rarely used. You can make a note, but hardly it will be used. If the angles are given of triangle ABC, we saw in orthocenter, right? This was what? Let's go back. This was like this tan. Here instead of tan you just write sine of twice of angle. x2 sine 2b, x3 sine 2c over sine 2a plus sine 2b plus sine 2c, and y coordinate will be y1 sine 2a plus so on divided by same thing 2a plus sine 2b plus 2c. But this you don't need to remember. Let's try solving at least question number 11. Find the circumcenter of triangle whose vertices are 0, 0, 3, 0 and 0, 4. If you remember the distance formula, we did one exercise where we had to find circumcenter using distance formula, but we don't need to do that here. Let's solve this. This angle is 90 degree. This is actually 0, 0, 3, 0, 0, 4, right? These are the coordinate given for question 11, and we already know the circumcenter of this one will be midpoint of line connecting A and C, right? This will be what? 0 plus 3 over 2, 4 plus 0 over 2, that is 3 by 2 and 2. This is the answer. The last concept we'll discuss before solving the last two questions, 12 and 13. So far we know what? Centroid we know, G, right? Orthocentre, that is H, and circumcenter, that is C. Alright, and the interesting fact is all these lie on a single straight line. If this is a triangle, let's say this is ABC, the point here, let's say this is altitude, right? So this will somewhere orthocenter will lie, for example H, and then draw median, probably here, median, maybe M. So somewhere G will lie here, right? G is what? Centroid. Also this is bisector, right? BM is equal to BC. Median is just bisector connecting to vertex, and when this becomes perpendicular bisector we get circumcenter, right? So maybe somewhere it is here, right? This point is C, this point is G. So all these three lie on same line. This is the property that we are not going to prove. We will just be using the result. All right. Also, if you see this very carefully, this is same as this one. Let's color it. This is same as this. These are perpendicular, so this one is same as what? This one, right? And obviously third one will be same. So these are similar triangle, and you know, at least we know for median this divides into 2:1. So this will also divide into 2:1, right? Triangle AHG is similar as triangle MCG. So what we get here, AH over CM is equal to HG. HG means orthocenter connecting to centroid over GC equals the median, right? That is 2/1 AG over GM. So this result is very important. When 3 points are given, H, G and C, this will be 2:1. So let's try to solve using this concept. Let the orthocenter and centroid of triangle are given, A and B. If C is the circumcenter of this triangle, find the radius of the circle having line segment AC as diameter. Points are given. A, that's basically your orthocenter, right? -3, 5. B, centroid is also given, that is G, right? 3 and 3. And circumcenter we don't know, right? That is, let's write X and Y. It says, find the radius of the circle having line segment AC as diameter. You have to find the radius of this circle for which the diameter is AC. So basically somewhere this point, middle will come, right? And circle will be like this. All right. So basically we need to find the point where this will be divided into half of that. To find that, we need to find the coordinate of C. This one divides into 2:1 ratio, right? Let's apply the section formula. So if we apply that, 2 times of x, 2x plus 1 time of 3. 2x minus 3 over 3 is what? This 3. So x will be 6, and again 2 into y, 1 times 5, 2y plus 5 over 2 plus 1, 3 equals 3. So y will be 2. Now we know this point, 6 and 2. The midpoint is very easy to get. Now we know this point, 6, 2. So H, G and C all are known. We just need to find this point. There are multiple ways to do it. You can find the length of AC, right? A and B is given, or you can say HC is what? 6 plus 3, that will be 81, plus 2 minus 5, 3, 9. That is 90. 3 root 10, right? AC is 3 root 10. So obviously the circle where this AC is diameter, the radius of that circle will be AC over 2. So radius is 3 root 10 over 2. That's the answer. The last question of this lesson. Let A, B, C, the points are given. Let's draw A, B, C. A, B, C is alpha -2, alpha 6, C is alpha over 4 and -2. What else is given? 5 alpha over 4 is the circumcenter of triangle ABC. 5 and alpha over 4, that is given. All right. So this point is given, and you know there will be circle that will be touching A, B and C, right? and the radius will be same, that is r, right? And if you see this question very carefully, the numbers, the coordinates are given so that you will get the calculation very easy, right? This radius is same as this radius, right? R and R. So what you can do, you can apply distance formula, 5 minus alpha square plus alpha over 4 plus 2 square is what? Again you have 5 minus alpha here plus alpha over 4 minus 6 square. These two are cancelled out and you're left with this one. So this will be same as negative of this or positive of this. Positive of this is not possible because nothing, no value of alpha will satisfy. Alpha plus 4, alpha over 4 will be cancelled out. So this will be alpha equals negative of this, right? So alpha over 2 is 6 minus 4, 2. Alpha is 8. When you know alpha, the coordinates are very clear now. The coordinates are what? Just put the coordinates. A is, sorry, not alpha. This will be 8 minus 2. B is 8, 6. C is what? Alpha over 4. So 2 and negative 2. If you see this triangle very carefully, what you will see here, 8, the distance of AC is what? 0, 0. And this is 8, this is 6, and this is 10. 8, 6, 10. You know, right? 8 square plus 6 square is 10 square. So this is definitely right angle triangle. So this will look like this one. C 2 negative 2, A 8 negative 2. This will be this side, right? B 8 6. This is right angle triangle. Why I'm drawing like this? Because AC is what? 6. This is AB is 8 and this is 10. Now we have the triangle. There are few things given for this triangle. We have to eliminate which one is not correct. Area is what? Let's calculate. Area is 1 by 2 base into height, 8 into 6, 24. Is this matching? Area is 24, so this is correct. Next is perimeter will be sum of the side lengths, 8 plus 6 plus 8, 10. That is how much? 18 plus 6, 24. So this is not matching, right? 24. So this is one of the options. Circumradius will be what? Circumradius, you know, this is right angle triangle. So this is mid of this point and radius will be this point. This one will be same. And the length of this one is 10, hypotenuse. So this will be 5. Circumradius is 5. So this is also correct. So far B is incorrect answer. In radius is how much? In radius is little bit tricky. In radius, if you remember the formula, you can easily do. If you don't know, you can derive it also very quickly. If let's say this is the triangle, this is the triangle and circle R, 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 right? This will be perpendicular. So if this is A, B, C, area of triangle is what? Half of C times R, right? This is perpendicular, plus half of A times R plus half of B times R. So this is basically area equals 1/2 of A plus B plus C into in radius. So in radius is 2 this over A plus B plus C. Sometimes this is written as like this, semi-perimeter also, area over semi-perimeter, A plus B plus C over 2. So what is the area? 24 and perimeter is 24, half of that is 12, so that is 2. In radius is 2. That is also matching. So B is the right answer, means incorrect value. So this is all about important points of triangles, and probably in the next video we'll be covering area of triangle. Alright, so see you in the next video. Bye.